Good morning, sir. Good morning, Rosana.
How are you?
Very good. Good morning, Daniel.
Good morning, sir.
Good morning, teacher.
Good morning, Matthew. Welcome, guys. Good morning, Mary. Welcome. You can start the class, teacher Sat.
Okay.
Okay, guys, enjoy the class. And remember, if you have some questions, you can turn your microphone or you write your question by chat and the teacher going to answer, okay?
Yes, teacher.
Okay. So we have 3 topics today. One variable, equations, and one variable equations and inequalities. The second one for today is equations and inequalities with absolute value, or you can say absolute value inequalities and equations. And the third one is equation of straight lines, parallel, and perpendicular lines. So starting with one variable equations and inequalities. Even last time we did the equations and the inequalities, we saw different types of equations, not the inequalities, but the equations. So an equation is one in which we have like two expressions, one expression here, and it is connected by the equal sign, and we have another expression here. So like these two expressions, and then they are connected by the equal sign. So that is what is an equations. So now we are dealing with only one variable equations. Like if you remember, like we can have equations in multiple variables, but now we are dealing with equations which only include one variable. Let's say we try to like think of some, let's say we just write, for example, 2x plus 5 equals to 9. All right, so that is a one variable equation because we only see the one variable x here. So let's make a scenario. Let's say we have let's say the price for a pizza is, let's say it's $5, let's say, and we have, let's say we have $80. Okay, how many pizzas we can get? So we can write like the price. So 5x, the price is the 5, x is the number of pizzas, should be equals to 80 because we want to spend $80 on it. Okay, so the price of one is $80. Like now we want to find the x, so we will divide both sides by x, we will get 16. So like we can get the number of pizzas as 16. That's like a one, that is like the one variable equations. All right, so similarly with equations, the equation now, let's say we have x squared plus 4x plus 4, or let's say x squared plus 4x equals to -4, like this. It's also one variable equation because you see there is just one variable in it. There is no y. We only see the x. All right, so we can rearrange it. We can write it like we can, and then either we can use quadratic formula or we can use the factorization, right? So we can factorize it. We can say x squared plus 2x plus 2x. We break the middle term into two numbers. We break the middle term into two numbers that when we multiply them, we get 4 because this is 4 and there is 1. So we get 4. But when we add them, we get 4 as well. So it's 2 plus 2, so like that. Then we take the x as common factor among these two. So x plus 2. And then again, we take the 2 common. So we get x plus 2. So, and then we, in these two terms, these are the terms because they are separated by the equal plus sign. So in these two terms, again, we have x plus 2 as common. So from the first, we left with x, and from the second, we left with, so we get the same answer. So x, so this is called the zero property, that when we get multiple factors which are equal to 0, we can write them equal to 0 one by one. So as it is the same thing, so we don't need to write it twice. So x plus 2 is equals to 2, so x is equals to -2. So that's how we can solve them. And this one is an equation for a parabola. So these are the one variable equations. Similarly, one variable with like instead of one variable equations, if we are having these signs instead, if the expressions are connected with these signs, this is less than, this is, sorry, this sign is greater than, this is the sign for less than, this is greater than or equal to, or equal to, and then the last one, this is like less than or equal to. So these are like, if the expressions are connected with these, then they are the inequalities. So we are looking for the inequalities that are in one variable. Let's say, for example, we have 4 over 9 minus x, it's greater than or equals to 1 over 9 minus 3 half x. So now this is a one variable inequality. It's a one variable inequality because we just see one variable, which is x here. So again, we can try to solve it. We can combine the like terms on one side, and let's say first of all we add 3 over 2x, because we see this is the negative 3 over 2 here. So we add the plus 3 over 2x on both sides. When we add the plus 3 over 2 on both sides, we get 4 over 9 minus x plus 3 over 2x greater than or equals to 1 over 9. Then the next thing is we can combine these two. So this is x over x, and this is 3 over 2x. All right, so we can rewrite this minus x as 2x over 2, because we want to make the common denominator so that we can add them, right? So it's 4 over 9, and then like the 2 is common, so minus 2x plus 3x. So we will just get like x over 2, and then we can also subtract 4 over 9 on both sides. So we will get x over 2 is greater than or equals to 1 9 minus 4 over 9. So 1 9 minus 4 over 9 is actually equals to, so x over 2 is greater than or equals to minus 3 over 9. So we have like x over 2 greater than or equals to minus 3 over 9. We can simplify it. It's 1 over 3. So x over 2 is greater than or equals to 1/3. Then we cross multiply. Then we cross multiply there. So x is greater than or equals to 2/3. Okay, so like that. So now if we see it on the number line, you draw the number line 0, 1, 2, 3. So we see that x the equal, like it is equals to 3 over 2. So we go to, no, sorry, 2 over 3. So 2 over 3 is actually less than 1, right? So it's here. That will be 2 over 3. And you see there is an equal to sign. So we will draw a solid circle. Then it's greater than, so like it's like you draw that, and it's the greater than numbers are on the right side. So you draw it on the right side. Like this. Okay, so this is the solution. That's how we are solving an inequality which is in one variable. So we can also have inequalities in quadratic or in more higher power terms. Let's say another example for an inequality in one variable is, let's say we have x squared minus, or let's say x cubed minus 4x greater than 0, right? So this is also a one variable inequality because we are just using one variable x. So to solve them, solve the inequalities like that, what we do it, first thing is write it like an equation. Okay, so we will write it like an equation. So x cubed, and then as you can see, we can take the x as a common factor, left with x squared minus 4 we can then now we're applying the zero factor property. We can write x equals to 0 and x squared minus 4 equals to 0. X squared minus 4, we can write it as x squared minus 2 squared. So then x minus 2, x plus 2 using the square property. So now we get x equals to 2, again applying the zero property, x equals to minus 2 and x equals to 0. So we got these three numbers. What we do is, now we draw the number line. We mark these points, so 0, minus 2 and 2. And now you see the actual function that we are using is greater than 0. Okay, so we will like have them open circles. We will have the open circles on it, just for, we will not have the fill circle because there is no equal to sign with it. So we will have the open circles. Now how we will decide that which part will be the solution and which one is not? So to check that, you make the table and then make the intervals. Okay, so let's pick any number from this interval, any one. Okay, let's say I pick minus 3. Okay, then I put it into my given inequality, that is x cubed minus 4x greater than 0. So now minus 3 cubed minus 4 times minus 3, that is minus 27, and then plus 12. Is it, so that is minus, let's say 15 is greater than, is minus 15 greater than 0? Answer is no. So
No.
this answer is no for this whole interval. All right, so we cross this whole interval. This is not the part of the solution. Then we pick another point from there. Let's say we pick minus 1, and then again we check it in there. So minus 1 cubed, and then 4 times minus 1. So if we do that, we get minus 1 plus 4, which is 3. So 3 is greater than 0, so that's yes. So this portion here is the part of the solution, right? So this portion, this interval here is the part of the solution. Like, so how we can write it? We can also write it from minus 2 to 0. Both hands are open, like there. This part is the, okay, now again we pick something from here. Let's say we pick 1. Pick 1 from there. Any, you can pick any point, but just for the easiness, I pick the 1 in between this interval. So it's 1. So let's try 1 cubed minus 4. 1 cubed minus 4 into 1. So that's minus 3. And is minus 3 greater than 0? Answer is no. So this portion is not the part of the solution. Then we take another 1 point from this side. Let's say I pick 3. Okay, so 3 cubed minus 4 times 3. So 3 cubes is 27 minus 12, that's 15. And 15 greater than 0? Answer is yes. 15 is greater than 0. So this portion also the part of the solution. So that is from 2 to, and it's going all the way up to infinity. Okay, you can write it positive infinity, or you can just write it infinity. Okay? Or infinite. Okay. So this is, and you don't close them because infinity is not a point. You cannot reach it. So you never close the infinity with the square bracket. You always put an open parenthesis. And since the 0 is also not a 2, at 2 it is 0, but we are looking for when it is greater than 0, not 0. So we cannot have that as well. So this one is, so the solution for that inequality that we just solved is these two intervals. And how we write them? We put a u between the intervals. This is means union. This portion plus the portion on this side, all of it. That's, these are the portions, are the part of the solution for this one variable inequality. Okay, so then the next thing is, Okay, so now we have our second topic, absolute value. Just give me 1 second, okay, please. Sorry about that. Okay, sorry. So now we are doing equation and inequalities that involve absolute values. Okay, absolute value equations and qualities. So let's see what the absolute value means. So the first thing absolute value is like absolute value of something is like always positive, or you can say the absolute value of something is always, absolute value of A is always greater than 0. So the absolute value of A is always greater than 0. Let's say if we have -3 and we do its absolute value, it will be equals to 3. Absolute value means distance from 0. Okay, let's say if I have -3 absolute value, it means I'm asking what is the distance of the point 3 or point -3 on the number line from 0. Okay, from 0 this is 3 units, 1 2 3 3 units far. Okay, let's say this is someone's house. Let's say this is our house. One of the friend lives 3 houses on the left and one of the friend lives 3 houses on the right. Okay. So what is the distance of from your
6
home?
units.
Yeah, so the distance from there to there is also 3 units, and the distance from there to there is also 3 units. So it means like either if we go into the left direction, the distance is still positive, it's 3. Either we go to the right side, the distance is still positive, that's 3. So that's what the absolute value do. That absolute values gives us positive answer. So the absolute value of x, like if we have absolute value of x, its formal definition is we write it as a piecewise function, and then it's like we say that x, the absolute value of x is equals to x if x is greater than or equals to 0. Like if x is greater than or equal to 0, this will behave, this function just behaves like as it is. But this function, this absolute value behaves like a, like it converts it into -x if the values of x are less than 0. Let's say if we have -3, so we will use this one. Negative times -3 will make it positive. But let's say if we have +3, then we will use the above one. That will just leave it as positive. Let's try some question with the absolute value with equations and inequalities. So let's say we have this is for the equation, absolute equation. Okay, let's say we want to find this. We want to solve this absolute value equation for x. So first of all, we cannot solve it unless we just have this thing on one side and everything else on the other side. So what we do is we add 2 first of all on both sides. So we will get 4. Then we will divide both sides by 4. If you remember on the previous page, we just saw the definition for it. The definition of absolute value is it gives us x if x is greater than or equal to 0, and it gives us minus x if x is less than 0. So what we will do is we will assume that when this thing is greater than 0, what we get it just like it is, 2x minus 1 equals to 3 for the greater than part. And when this inside thing is negative, then what happens, we put it as a negative. So what we will do is 2x minus 1 equals to negative 3. So basically what we do it, we write it 2 times. One time with the plus sign as it is, this as it is, and then one time with the negative. So now let's solve. So 2x equals to 4, because we will add, then x is equals to 2, and from here what we get is 2x equals to negative 2 and x equals to negative 1. So if I will, so the point, like the x has 2, if I put in 2 here, and if I put in minus 1 here, then the answer of this thing is, then this whole thing is 10 units far from the 0. We can also check them. We can also check the absolute value equation if we want to. Let's say if I plug in minus 1 here, and it should be equals to 10, right? We should get it equals to 10. If it is equals to 10, it means then it's true, then it works. So 4, this is minus 2, minus, that will become minus 3, and the absolute value makes it plus. So 4 times 3 minus 2, that is 12 minus 2, that is 10. You see, so when I plug in the x as minus 1, the distance of this absolute value equation is 10. Similarly, if we plug in 2, we will also get 10. We can also try the plug-in in 2. So 4 into absolute value of 2 into 2 minus 1 absolute value and then minus 2. So 4 into 4 minus 1. So like the answer of 4 minus absolute value of 3 is again 3. So it will be 12 minus 2, that will be 10. So you see, for these 2 points, the x equals to 2 and the x equals to minus 1, they are 10 units far from the 0 for this absolute value equation. Let's say, okay, so there is a question. Let's say if I say that 2x plus 4 is absolute value of 2x plus 4 equals to minus 2. Okay, so how we can solve it? Anyone want to tell me?
Subtracting 4 on both sides.
The thing is, first of all, if we follow the method, 1 times write it equals to minus 2 and 1 times with the positive, then we can do it. The method is that. Okay, but the thing is, we cannot do it because I told you this is the absolute value. This is the distance. What is this? Distance from the 0. So can the distance from the 0 for something, for anything, be equals to negative 2? It's not possible. Okay, the distance from anything cannot be negative 2. So this one have no solution. If you see an absolute value equation absolute value equation equals to a negative number, the answer is no solution. You cannot solve it because the distance cannot be negative. And then we can also have some scenarios when we have the absolute value on both sides. Okay, let's say we have 2x minus 1 absolute value equals to the absolute value of 4x plus 9. Okay, now in this case, how we will write it? Okay, we will follow the same step that we did before, but one time we will write it as it is, just as it is, without, just remove the absolute values and write it. And one time you leave the left side as, you can like leave the one side as it is. I usually leave the left side as it is, and with the right side put the parentheses and the minus outside. One time you write it as it is, and one time you multiply the right side with the, like you remove the absolute value thing and then you multiply it with the minus out there. Again, this side we can combine the terms, you can have 1 on the other side, so, or, and then we can even subtract 2 on 4, like 2x minus 4x equals to 10, so minus 2x equals to 10 and x equals to minus 5. Then
Teacher,
yes,
right there where it says 2x, why don't you write the -1 anymore?
this minus 1,
Yeah, down there on the second,
I added it,
Oh,
I added
yeah.
it here.
So you took it to the other side. Okay.
Yes, like I did what I did as +1 +1 and then we took it to the other side. So again, in this one, first of all, before we solve it, we will distribute the negative. So, and then again, we are adding the 1 on both sides. We added the 1 on both sides. So this one, this side is gone, and on the right side it is there. So now it's 2x equals to plus, oh, minus 8, right? Then we come, then we add the 4x both sides now. So it will becomes on this side, and from this side it will be vanished. And then it will be 6x equals to -8. So x equals to 8/6, which is -3/2. So we get these two answers. We get these two answers for this absolute value equation. So like, if don't be confused, even if you get the absolute values on both sides, we can still solve them by removing the absolute value and writing it once as it is, and then removing the absolute value and then writing it and multiplying it with the negative outside there on one side, either one side. You can even do it with the left side or the right side, but usually we do it on the right side. Okay, so similarly, like we had the absolute value equations, we also get absolute value inequalities. Absolute value inequalities, let's say I have 3 and 3x plus 9, and let's say I say it is less than 36. What I want to know is I want to know that for which values of x, will the absolute value, the distance will be less than 36 for this thing. So as I said, we cannot solve it unless we just have the absolute sign thing on one side and everything else on the other side. So first of all, we will divide it. First of all, we will divide it with 3. And then we get 12. Okay. Now, in case of equality, when there was equation, what we did, we write it 2 times, right? Like we just wrote it, like if we try to follow that, we can write it, if you say that we follow the pattern, and we write it like, in case of equality, it does not make sense, right? In case of inequalities, it does not make sense. Like we are saying that this thing is less than 12, and then we are saying this thing is less than -12, right? So you cannot do it this way when we are dealing with the inequalities. So what we do is, how we break the inequality, when we want to remove the absolute value sign is you once you write the -1 on the left side, then you remove the inequality sign, and then you leave the positive one like this. Now we will get these two inequalities. Now we will break them into two inequalities: -12 less than 3x plus 9 and 3x plus 9 less than 12, because we know that when we multiply an inequality by a negative number, its direction flips. It changes its direction. Like before, if it was this way, if the arrow was pointing toward 3x plus 9, once what we did, we multiplied it with the negative. So when we multiplied with the negative one, this is negative, then what happened? Its directions is its inequality sign is now the other way. Okay, so now let's solve them. So -12, we can subtract 9. So we get like this is like -21, and then x, so like -7 is less than x, or similarly I can write it as x is greater than -7. That's the same thing. This and this, they are the same thing. There's no difference in them at all. Here I'm saying -7 is less than x, but here I'm reading it as x is greater than -7. So that's the same thing. Like either if I say that -7 is less than x, or if I say that x is greater than -7, it's technically the same thing. Now we solve the other part. So, oh, sorry. So we subtract the 9, right? So it will get 3x less than 3, so x less than 1. So now we get two answers for this absolute value inequality, and let's see if we can try to like draw. This is, let's say, the point -7, and this is the point 1. There is no equal to sign, so the round open circles, no filled circle there. What we are saying is x is less than 1, x less than 1, which is this values, right? And then we are saying that x is greater than or equals to -7, which is this side. Or the other way around, if you want to try it, we can do is like we pick these points. Now let's check them. Let's check this point from here. So let's say if we try -8, right? Let's try -8. So 3, absolute value of 3 times -8 plus 9. Okay, so 3 times -8 is -24 plus 9. That is 3 times, what we get here is 3 times 16, right? 3 times 16 is like 45, right? And the inequality says it's less than 36. Oh, not 48, sorry,
48.
Yeah, so okay, so that's 48. So we get it's less than 36. Is 48 less than 36? No.
No.
This is not the solution. Okay. Then we check one point from here, which I will pick 0, because 0 is the easiest. So 3 into 0 plus 9, which is 3 times 9, which is just 27. And is 27 less than 36? Yes.
Yes.
So this is the part of the is the solution up to there. And then again we pick in 2, let's say 2 from here. So 3 times 2 plus 9, that will be 6 plus 9 is 15, right? And then 3 times 15 is, absolute value of 15 is 45, which is not less than 36, which is not less than. So this is also not. The other way around that I showed you before is that it was showing us that the x less than 1 this side and this greater than 7. So you just see where the common portion is, where both of these color exist, the blue and the yellow. All right, so the blue and the yellow exist in this portion. Both of them exist in this portion here. So this is the part where it is the solution. So you can just do it this way. You can graph them and then you can figure it out where is the common portion, or you can take the points from each interval. You can take the point from each interval and then you can check them. Okay, now I have a question for you. Okay, you need to tell me, let's say I have 5x plus 6 and okay, how we will solve this. Anyone have any idea? No?
So you should rewrite 5x plus 6.
Should we rewrite it like this? Oh, actually negative times negative will make it positive, right? Should we rewrite it like this?
Maybe, I'm not sure.
Okay, but like, let's say if it would be 6, positive 6, then we would have it, then if let's say if it is positive 6, then we would have written it like negative 6 and then the arrow there for 6, if it would be 6. Okay, if it's like greater than 6, then this is correct. But now what we are saying, now just try to understand what this equation is saying. What does this thing represent? This thing represents distance. And what we are saying, that the distance of something, whatever it is greater than -6. Distance of something is greater than -6. Distance of anything is greater than -6 because the distance can be 0. It cannot be negative. Okay, the minimum distance between two things can be 0, but not negative. So if you see something like this inequality, it's a true statement forever. It's a true statement for all values of x. No matter whatever you put in the x, this absolute value thing, it will be positive. Okay, positive is
So this
always
equation
greater
has a
than.
solution.
So all the values of x are its solution,
So
because
this
positive value is always greater than negative value. And let's say if I have another one which is less than negative, what I'm saying now, okay, what I'm saying now here is the distance between 0 and something is less than -6. But does it make any sense? No, I'm saying, what I'm saying here is distance between the point 0.
Mom, sorry to hold you up. You're being disruptive. You're being eruptive. I'm trying to ask the teacher a question and you're still talking over me, Mom. Can I please ask the teacher a question? Mom?
So,
Oh, sorry. I didn't notice my mic was on. Sorry, I apologize.
So what we are saying here is the distance between the 0 and something is -6. So it is not possible. The distance between any two things can be 0. That's the minimum it's possible. If they're far apart, it will be positive. But we cannot have the negative distance. There's no idea of negative distance. So it's not possible. So if you see an inequality which says that it's less than a negative number, then not possible, no solution. And if you see it's greater than a negative number, then it's true for all the statements. It's true for all the, it's a true statement. It's true for all the values of x. Okay, now this is our last topic, third topic for the day is equation of straight lines, equation of lines, parallel and perpendicular lines. So let's start with the equation of lines. Equation of straight lines. So let's say there is basic form is the slope intercept form, which is y equals to mx plus b. M is the slope and b is the intercept.
What is x?
Oh, x is the variable. Like x is the x values, like x-axis values. These are the x values. These are the y values, like that. And the slope means the gradient, rise over run. The formula for slope is y2 minus y1 over x2 minus x1. That's like if we have 2 points. Let's say we have point x1, y1 and x2, y2. If we have these 2 points, then how we can find the slope? Y2 minus y1 over x2 minus x1, or sometimes people call it rise over run, or sometimes it's also called as change in y over change in x. So change
I
in
like
y
to
over,
call it rise over run.
yes, rise over run is a general term people use, but when you're solving it, you need points, or because otherwise if you're shown the graph, you can use the graph. But if the graph is not given and the points are given, then you can use the points to find the slope like this using the points, 2 points. So this is one of like the equation for this line, y equals to mx plus b. There is another equation for the line is like another way to write, that is y minus y1. Here x1, y1 is a point, and m is slope. This one is called slope point form. This one is slope point form for the equation of line. It has a slope, it has a point. We need 2 things, slope and a point to graph, like to find the equation for this line. Okay, there is another one which is called the standard form.
Teacher.
Yes.
So is it like y1, y2, x1, x2, or for the
We
slope
need
point form?
we need 1 point, just 1 point. Let's say I know the slope. I know that the slope, let me show you. Let's say I know the slope is 2. Let's say m is 2 over, let's say 3. Okay, and I'm given a point that this line passes through the point 2 comma 4. That's it. Okay. I have a slope, I have a point. So the equation that I can write from this for this one is y minus 4, because 4 is the y1. See, y minus 4. This is the point y1 equals to 2 over 3 into x minus 2, because 2 is the x1. This is x1 y1, and this is the slope m. So if we are given the slope and a point, we can write it the equation of line using those 2 things. If we are given 2 points, we can find the slope and we can use the point. If we are given a slope and a y-intercept, the point is the y-intercept, then we can use the slope-intercept form. And this is the standard form. Let's say ax plus by equals to c. A and b are the constants, the numbers, coefficients, and x and y are the variable. So this is the standard linear form, standard form of line. let's just try some. Okay, so now let's look at the perpendicular, parallel, and perpendicular lines. Okay, just for the reference, if a line do not have any slope, like the x-axis, let's say the x-axis, the equation for the x-axis is y equals to 0. This is the equation for x-axis, and the equation for the y-axis is x equals to 0. This is, so you might, it might look opposite, but it's not. Okay, the equation for x-axis is y equals to 0, and the equation for x-axis is, oh sorry, the equation for x-axis is y equals to 0, and the equation for the y-axis is x equals to 0. X equals to 0 represents vertical lines, okay, and y equals to some numbers, like say vertical lines are x equals to a, any number, and the horizontal lines are represented by y equals to some number, any number b. If we have seen something y equals to b, then it's a horizontal line. The horizontal line have the slopes 0. Slope is 0. For the vertical lines, the slope is undefined or infinity. Okay? Undefined or infinite. Okay, so now we are talking about the parallel and the perpendicular lines. Let's say the two lines, they have the same slope. We have two lines that have the same slope. Let's say the slope, or we have a line here and then another line here, just like the railway track. The two sides of a rail track, they never intersect with each other. They keep moving like the straight. So they are the parallel. They are parallel. So this and this is parallel. These are, let's say its slope is 2 and its slope is also 2. No matter they are at different places, but they are parallel lines. So the thing is, parallel lines have same slope. Have same slope. Parallel lines have same slope. All right. So let's say I gave you an equation, y equals to 3x plus 5, and I gave you a point 3, 2. I ask you find a line parallel to given line and contains point 3, 2. So we are trying to find a line which is parallel to this line and it passes through the point 3, 2. So what will be the slope of the parallel line that we are trying to find? Slope of the parallel line, that will be 3, because the slopes of parallel lines are same. And the point is already given, so we can write it y minus 2 equals to 3 times x minus 3. So that's the, and we can even convert it into slope-intercept form by, sorry, y minus 2 equals to 3x minus 9. We will add the 2 on the other side, so y equals to 3x. So this is an equation of parallel line. This is an equation of parallel line to the given line here, this one. So next thing is the perpendicular lines. Perpendicular lines have slopes that are opposite reciprocals. Opposite let's say I have the let's say the given equation, I have a slope m1 of the given equation, that is a, all right, any number a, or let's say a over b. Okay, the slope of one line. Okay, so slope of parallel line, slope of the perpendicular lines are represented by this symbol. Okay, and the parallel lines are parallel. Okay, so just writing parallel line symbol is this.
Are you using the reciprocal?
Yes, so slope, this is like the symbol for the perpendicular line. Slope of perpendicular line will be minus, because it's opposite. If it is plus, it should be minus. Reciprocal will be b over a. Okay, so there is another formula. If two lines are perpendicular, then m1 is the slope of the first line times the m2, which is the slope of the second line, is equals to -1. So the product of m1 and m2 is -1. The slopes of two lines is -1. Let's say, just quickly look at the question. Let's say I have y equals to 3 over 2x plus 5. Okay, and let's say the point is 0, 5. No, let's not. Yes, so let's say that we want to find perpendicular line to this. So slope of perpendicular line will be opposite reciprocal. This is positive, so that one will be negative 2 over 3. And the point is given. This point is also y-intercept, because the x coordinate is 0. When the x coordinate is 0, that is the y-intercept. So we can write it y equals to -2 over 3. This is the y-intercept. This is slope. This point is the y-intercept, which is b. So this is the line. This is the perpendicular line to the given line. These two lines, if we will draw, or if we see, they will be perpendicular. Like this one would, the first one, the original one, that would be like going up like this, and the perpendicular one would be going down like this. They will be crossing here at the point 0, 5, and the angle between these two will be 90 degrees. This angle will be 90 degrees. So these are the perpendicular lines. Okay, so I guess our time is up. If anyone have any question.
Guys, everything is clear? Or do you have some questions?
Yes, teacher. Yeah, everything's clear.
Okay, very good, very good. Daniel, Luciana, Ferdy, Matthew, thank you so much, Teacher Sad. Excellent class. Always your class is very good. Excellent. Thank you, guys. Enjoy the rest of the day and be pending for next class, okay? Have a wonderful day, guys.
Bye, teachers.
Thank you,
Have a good
teacher.
day.
Bye.
Bye, Major, Luciana, bye.